One of Guyana's most impressive engineering wonders stretches approximately 1.85 kilometers and connects the country's east and west banks. It features a high-leveled fixed span that provides a horizontal clearance of about 32 meters and the vertical clearance of 7.9 meters for small craft. Additionally, its ingenious retractable span provides clearance of 77.4 meters, allowing large vessels to pass through, a crucial feature for maintaining the flow of maritime traffic. Although originally built to last only 10 years, this wondrous floating structure has now stood the test of time for nearly 50 years. To this day, this structure remains the world's fourth longest floating bridge. This is the Demerara Harbour Bridge, old and new. Bridging the Demerara River is not a modern afterthought, but a vision that began to take shape several decades ago. Let's take it back to the early 1950s. In the early 1950s, as British Guyana was experiencing both demographic growth and increasing economic activity, a critical need emerged to improve connectivity between Georgetown and the vast expanses of West Demerara. Before the construction of a permanent structure, ferry services were the primary means of crossing the river, a system that was not only time-consuming, but also unreliable during inclement weather or peak travel periods. A pivotal moment in the evolution of this vision occurred on May 23, 1952. On that day, the Legislative Council of British Guyana debated and subsequently approved the motion that is now recognized as the first substantial official step towards bridging the Demerara River. Introduced by the Honorable Captain J.P. Coghlan, the motion passed by a narrow margin of 12 votes to 9, highlighting that even then, the proposal was both ambitious and somewhat controversial. This resolution called for immediate preliminary surveys to be conducted, including subsoil borings to determine the suitability of the riverbank strata for supporting bridge piers. The motion also recommended that an accurate survey of the proposed site be carried out and that a select committee be established by the governor to finalize the design of the bridge. In addition, there was a proposal to advertise for tenders and explore financing options, such as floating a loan, to secure the necessary funds for the project. The reasoning behind this early push was multifaceted. The proponents argued that constructing a bridge would not only provide a more efficient means of transportation for passengers and goods, but would also yield significant economic benefits. It was estimated that bridging the river could lead to significant savings in transport costs and boost the time between Commerce and Georgetown, as well as provide a long overdue outlet for the rapidly growing population of the capital city. Essentially, the bridge was envisioned as a catalyst for economic development, a means to foster greater social and commercial integration across the region. Even though no immediate construction followed the 1952 resolution, the motion was far from futile. It established an official framework for conceptualizing such an ambitious project and laid the ideological and administrative foundation for what would eventually become the Demerara Harbour Bridge. On May 29, 1976, the groundbreaking for the Demerara Harbour Bridge marked the commencement of an ambitious project that would ultimately redefine transport and commerce in Guyana. Central to the planning phase was the input of Captain John Patrick Coghlan, a respected engineer whose ideas significantly contributed to shaping the bridge's foundational design. Coghlan's approach emphasized the innovative concept of a floating pontoon bridge, one that relied on a series of pontoons to support its vast deck rather than traditional fixed supports. This design was particularly well suited to the dynamic and sometimes unpredictable conditions of the Demerara River, as it allowed the structure to adapt to changes in water levels and currents. The unique engineering required innovative techniques in welding, soldering, and metal fabrication, pushing the limits of what was considered possible in the region. Constructing such a vast and adaptive structure required significant resources. Approximately 80,000 tons of steel were used, much of it soldered and molded on site using advanced metal fabrication techniques. Although early estimates placed the project cost between $4 and $10 million, the final expenditure reached roughly $40 million, reflecting both the complexity and the ambition of the undertaking. After 2 years of hard work, the bridge was completed just in time for its ceremonial opening in early July 1978. The inauguration was celebrated as a major milestone in Guyana's development, signaling a new era of connectivity and economic potential. Even though the Demerara Harbour Bridge was originally built with a design life of just 10 years, it has defied expectations. Now almost 50 years old, this floating structure continues to serve as a critical artery between Guyana's east and west banks, a testament to the visionary design and relentless maintenance efforts that have kept it operational long past its intended lifespan. Its enduring strength lies in its innovative floating design. The system of 121 pontoons working in harmony to support 61 spans has allowed the bridge to adapt to the dynamic conditions of the Demerara River tides, currents, and seasonal fluctuations that would have posed significant challenges to a conventional bridge.
The design, as I said earlier, entails 61 spans. During that time, it was predominantly what we call unifloats. Now we're using pontoons. The unifloats provide the same flotation as a pontoon. And currently you have 121 pontoons that consists of the buoyancy of the bridge. You have 243 buoys. You have a total of approximately 35,000 feet of wire rope. You have a total approximately about 72,000 approximately that feet of chain. And you have a total of 726 5-ton anchor blocks. These blocks are in cluster of 3. So to every buoy that is in the water, you have a anchor chain link to the buoy. The cluster pile is about 15 tons. Then the buoy is linked to the pontoon via sheaves, wire rope, and then you have winches that are used to adjust the buoyancy or the alignment of the bridge. So it's a combination of anchor blocks, chains, buoys, wire ropes, and the pontoons. As I said, you have 726 anchor blocks lying on the riverbed. And these anchor blocks, they have highs, what we call highs, which is about a 1-inch thick metal is cast in the block. And those blocks are linked via shackles. And then you have the chain. There's a chain connected to them. And that chain is to the surface of the water, connected to buoys. These are some metal, hollow metal component that are floating. They float. And then from the buoys now, you have what we call sheaves. It's like a pulley, and then you have the wire rope passes through the pulley. So as you have movement of the water, you have adjustment. And those wire ropes now are then linked to the pontoon via the winches. So based on the tide, you can do adjustments, right? You have the logs we've adjusted the tension of the wire rope, chain, buoy combination that provide that stability. So the main component that provide that buoyancy or the floating of the bridge are the pontoons. That is the 121 pontoons. You have two different sizes. You have what we call the extra large, and you have the small pontoons.
Every day, the Demerara Harbour Bridge is a hive of activity. In its early years, around 9,000 vehicles crossed the bridge daily. Still, with the continuous growth of Georgetown and the surrounding regions, current estimates indicate that as many as 14,000 vehicles traverse this vital link each day. This impressive volume of traffic translates not only to thousands of commuters, but also to a significant movement of goods, connecting rural communities with urban markets and facilitating economic activity across regions. Maintaining a structure of this magnitude and age is no small feat.
Now, one of the uniqueness about the bridge is in what we call a sectional bridge or panel bridge. So you have components that are connected one to the other, either by pins or bolts. So that gives you the option of removing a component when it is bad or damaged and replace it. So for example, the sides of the bridge, you have panels, and all those panels are linked via bolts or pins. So if you're going to do a repair to a section, you remove the deck plates. Back those days, deck plates were not welded. They were secure by a different method that what we're using right now. So you had to unscrew those components, and you can retrieve the deck plates. We have the end posts. Those are also pin located. They are secured by pins. You have the transom beam, you have rakers, you have other components. So the access to repair or replace is much more flexible than a fixed bridge. And over time, the local knowledge would have increased and improved, and that is what caused the sustenance of the bridge. Not only the companies as Demerara Bridge Corporation employees, you have other local companies who are part of the maintenance regime. If you do the proration now, you have approximately 30,000 vehicles transiting the bridge, either east to west or west to east. The capacity of the vehicles that are transiting the bridge are much more in terms of weight. So what we are doing right now, or from when I took the reign of being general manager, we have what I will dub as we are doing proactive. We're doing day-to-day inspection. So we have teams going on the bridge on a daily basis, making sure that we cover the carriage and undercarriage, all the necessary key components. You have zone that we call braking and accelerating zone, when the vehicle will accelerate in speed or reduce in speed. And you have key components such as the chains, the wire ropes. Also for the retractor span, you have the rollers and other components that need to be inspected apart from the deck plates on the bridge. So we do a daily routine, morning, afternoon. And then out of those inspections, we will then prioritize what are the important work to be done in terms of maintenance or replacement. If the maintenance work are major, clearance will be sought via minister, because the bridge will have to close to most time 4 hours. If they are minor work, we do most of the work 10 p.m. to 4 a.m. within that period of inspection.
As Guyana faces mounting challenges from an overburdened and aging Demerara Harbour Bridge, the need for a modern, resilient replacement has never been more urgent. Decades past its original intended lifespan and strained by ever-growing traffic, the old bridge has become both a bottleneck for commerce and a costly maintenance challenge. Its limitations not only disrupt daily commutes, but also impede the efficient movement of goods, a critical factor in Guyana's economic growth. In response, the government embarked on constructing a state-of-the-art Demerara River Bridge, a fixed 4-lane high-span cable-stayed structure designed to meet the demands of the 21st century. Valued at approximately $260 million, the new bridge is engineered with a driving surface of 23.6 meters across a 2.65-kilometer span. Its modern design eliminates the need for retraction to allow maritime traffic thanks to a generous 50-meter fixed high span and a clearance that permits large vessels to pass unhindered. This means that once completed, the bridge will dramatically reduce travel delays and congestion, enhancing both road and maritime connectivity. While on site, we spoke with Patrick Thompson, the project manager at the Ministry of Public Works, who walked us through the extensive process behind planning and bringing a project of this magnitude to completion. The timeline for this project meant working around the clock.
So the bridge is actually comprised of one complete structure from east bank to west bank, measuring about 2.97 kilometers. So it's just under 3 kilometers, the entire bridge from east bank to west bank. However, from a construction perspective, the bridge is divided into 3 parts. We call one is the eastern approach bridge, that's the one on the east bank. We have a western approach bridge, and then we have what we call the main bridge. Now, the main bridge is about 570 meters that goes over the navigational channel. Right? That's where the cable stay section of the bridge is located. The main bridge was built in order to accommodate marine traffic that would need to pass through the harbor, right? So the vessel that was used, the design vessel, or the most critical vessel that was used for the design of this bridge was a vessel called a Handy Max vessel, right? Which requires a vertical clearance of about 48 meters. We actually have out there a clearance of about 50 meters from the median water level, right? That's a huge container vessel I'm describing. And it also requires a horizontal clearance of about 205 meters. We have more than 205. We have a 300 meter clear span out here, right? So in future, as Guyana transforms, as our economy expands, we will be able to accommodate much larger vessels into the harbor, provided that the channel is sufficiently dug and maintained to accommodate these vessels. Yeah. It was sometime around 2013 when the then Minister of Public Works, Minister Ben, he called me and he said, Patrick, we need to start planning for a new bridge across the Demerara River, and we need to start doing the studies and the designs that will facilitate that. And he said, you know what, we're going to do the studies with using our local engineering resources. So you put together your team, as well as we have some senior engineers in the private sector. We'll bring them together and we will develop a prototype for a bridge across the river. Those were the first set of conversations we had, and we were successful with the help of some of our local engineering. We did have guidance from a Trinidadian professor / engineer at that time. He's now deceased, but over a period of about 6 months, we developed the first pre-feasibility study for the new Demerara River Bridge. Subsequent to that, a full feasibility was done by a Dutch company that looked at several possible locations for the siting of the bridge. This was one of the locations, and there were about 5 others, including farther north, closer to Houston area, and farther south at Good Hope, Laurentia Potentia area. And so those were the very early planning stages of the project before we finally got to the point where a decision was made by His Excellency President Ali that this was going to be the location of the bridge. It was going to be a cable stay bridge, and we were going to do a design build project, which means we were going to hire a competent construction firm that has the capacity to both design the bridge and build the bridge. So we went out a tender process, and after several rounds of negotiation, we finally awarded the contract to China Railway Construction Limited, which is part of a consortium of Chinese firms that is currently building the bridge. When this bridge is completed, it'll be nothing short of a miracle, right? Construction in a timeline like this only happens in Asia or in China, probably to be more specific. The first pile for this bridge was constructed in December of 2023, right? That's just about a year and a half. In a year and a half, and well, we are a few months from the actual completion of the bridge. So this bridge is going to be built in much less than 2 years. That's a feat achieved only, like I said, in China. And of course, it's a Chinese construction firm that's doing it. I have done the research on comparable structures like in North America, and a bridge like this would normally take about 4 years, 5 years, 6 years to be completed. So by all means, what we are achieving in this country is monumental. And of course, it's a collaboration of the Chinese construction company with our local resources, our engineers, planners, technicians that are supporting the project, as well as the supervision of Politecnica, which is an Italian firm that was awarded a contract to be the engineer or the supervisory engineer for this project. Based on the most recent progress report, we have finally hit the 90s for the percentage completion for the project. We're somewhere around 91% as we speak today, right? So we are on the last lap, if you'd like, and you will see some footages of how close we are to really completing this bridge. You must have the appreciation. I said it's a monumental task that is being done, and work is being done on a 24-hour basis here. We have more than 1,395 employees, I said, mostly Chinese, but a fair percentage of Guyanese, Venezuelans, Cubans, and other nationalities working on this project night and day. And we hope that by August 31st, this bridge will be completely completed and ready to be commissioned.
Construction is well underway under the joint leadership of China Railway Construction Corporation International Limited and its partners. Recent updates indicate significant progress on key structural components, from completed temporary structures and approach roads to the installation of major precast girders and piers. Although the project has encountered typical delays, the government remains steadfast, with revised completion targets set for the end of August. These adjustments reflect a commitment to ensuring that every facet of the bridge meets the highest international standards for safety and durability, promising a lifespan of at least 100 years. The bridge's marvelous design isn't something that is done overnight.
This being a mega infrastructural project for Guyana, right? As you can see, it's all reinforced concrete, which requires a mass volume of aggregate, sand, cement, critical components to make this come together as one, right? Right now we're on the main bridge, right? As you can see, there's like a double H tower with in engineering, we call it, you have a double plane of stay cables which would support the cable stay bridge deck, right? And the reason for this being so long is so that you don't have to worry about opening and closing of the existing bridge, right? Because now ships can travel through the main navigational channel without obstructions.
Building such a structure doesn't come without its challenges, especially when over 1,400 workers are involved.
We're working currently at about 120 meters right now, which is pretty high. So I have a team out here monitoring, ensuring this happen, doing daily toolbox talks with the team, And if there is something more that's changing, maybe the weather, then I will stop. We will have another session, a discussion, and then we'll send them back out to work. We have about 800 Chinese here currently, and I have about 500 Venezuelans. And on the local side of things, we have about 400. Once the employees start working, there are JSAs, which is job safety analysis, that I utilize to train the employees in the field. Basically, there is a daily checklist, especially with any equipment on site, there's a daily checklist. That starts from the generators, the electrical boxes, and there's a checklist done. Once that's done, we would have the talks with the operators. And again, I have a team, the supervisors. They will ensure anything that's traversing around the equipment. I have banksmen with the equipment. So there's always someone there watching.
Beyond easing traffic woes, the new bridge is poised to be a catalyst for nationwide socioeconomic transformation. By slashing travel times, it will free up millions of productive hours currently lost in traffic congestion, a benefit estimated to save billions of dollars in economic output. Moreover, improved connectivity between regions will stimulate investment, foster industrial growth, and create job opportunities, while also enhancing the quality of life for thousands of Guyanese who will enjoy shorter commutes and more time with their families. In essence, the Demerara River Bridge represents not merely an infrastructural upgrade, but a visionary leap forward for Guyana, a strategic investment in a future where efficient transportation underpins broader national development and prosperity. The journey of the Demerara Harbour Bridge has been one of vision, resilience, and unwavering commitment. From the ambitious plans of the 1950s to the dedication of the engineers who breathed life into the floating structure, this bridge has become a symbol of Guyana's determination to unite its east and west. Its innovative design and enduring strength have not only overcome what once seemed impossible, but also sparked economic growth, allowing the movement of goods and people far beyond what anyone first imagined. Now, as we look ahead, the construction of the new Demerara River Bridge ushers in a new era of connectivity. With its state-of-the-art features, the new bridge will elevate the country's standing on the world stage. It offers the promise of colossal project completion as the nation expands into exciting new economic potentials. The benefit of this successor project will ripple across the nation, transforming daily lives, creating jobs, stimulating investment, and reducing time lost in traffic, ultimately driving Guyana's progress forward. The Demerara River Bridge is more than just an infrastructural marvel. It represents the nation's burgeoning spirit of growth, perseverance, and forward thinking. Once complete, the new link is setting the stage for a prosperous and united future, where connectivity, progress, and opportunity flourish, and where the dreams of yesterday become the successes of tomorrow.